Or I could. All right. How was the long weekend? I agree. All right, so we're going to crank through 2.6 today. A lot of this stuff you've already seen, I think, with rational functions. So a rational function in general is just a poly over a poly. So give me a nice polynomial that you like. X squared plus x plus 1 over. That just comes out to 1 then.
X squared plus 2x plus 1.
All right. Okay. And the list goes on and on, right? Okay, this notation will be a little bit new to you. So you know how we use limits for end behavior, right? We haven't used it where we had like a physical number there yet, right? It's always been infinity or negative. So this means C plus means C from the right, and C minus means C from the left. Okay? So let me just jump into an example to show you. So I'm just going to draw our little friend today. Okay. So here's
stick figure.
So the thing is you have to do it really fast or else it'll break apart.
I know.
So I had to be
The
sloppy.
smart board's evil. That's what I figured it was.
Oh.
I didn't say it was you. I thought it was the smart board. Smart
Okay.
boards are horrible, horrible, evil.
Can you go back to the formula?
So it's any old thing you want there, Josh.
Okay.
We just made that one up.
Oh, okay.
Yeah. Oh my.
Actually,
Don't start that. Did Justin Blake tell you to start that?
Brian, my brain's up.
Remember Justin Blake?
Yeah.
He and I were friends.
That used to be a thing they did all the time in class. Yeah. All right,
SpongeBob quotes in general, or is that?
just ravioli.
Oh.
Okay, so here's one, right? Here's one. You with me back there, gentlemen? Okay. 1 from the left. So here's 1, here's the left of 1, yes? So if I'm approaching 1 from the left, where's my guy going? Down where? Negative infinity, right? The y coordinate. Let me do it again. As I go towards x equals 1, the y coordinate is going towards negative infinity. With me? So the answer to this limit is negative infinity.
This is essentially just the same stuff before, but with asymptotes.
Exactly. Now from the other side of 1, so from the right of 1, where's he going? Up to positive infinity, right? Now, doesn't that mean there would have to be an asymptote there if it's doing that at 1, right? So this is creating our VA at x equals 1. Now, these other two questions aren't new, right? If I go to infinity, where is it going? Y coordinate is going towards 1. To negative infinity, 1, and that's creating the AJ. Yeah. Any questions on that new notation here with the 1 minus 1 plus? All right. So domain, we've studied this quite a bit. We're going to go over it again. With rationals, you know that the domain, the only issue would be when the bottom is 0, right? And we exclude them from. So bad values here are 1. Anything else? Negative 1. Okay. And remember, probably the best way to do this would be to go ahead and factor the bottom. And then we can see that those two excluded values would be 1 and 8. So domain negative infinity to negative 1, negative 1 to 1, and 1 to infinity. Now that means there's vertical asymptotes there, right? At 1 and negative 1? Because nothing cancels out. So VAs are plus and minus 1. And we're going to go over this formally later. Brian, you all right back there? Okay, L?
I really like eggs.
Okay. Do you guys remember where the HA would be located? Remember HA?
It's like, doesn't it have something to do with hours?
0. Remember why? The same power. Bottom power. Yeah. Bottom figured. What is the power of the top actually, guys? 0. Technically, yeah, technically the top has a 0 power and the bottom has a 2 power. So the bottom's bigger, so we have an HA at y equals 0. Good memory on that. All right. I like when we often, when you guys like, you get pieces of it come together, you know? It's nice. Okay, so I'm gonna just graph these two so far. So when I have you graph something like this, I look for the asymptotes, and then the additional points, I would just have you use your calculators for. So I like to pick some smart points. Don't just randomly pick things. So make a little table. So like 2 points in every little region is enough. So like I like to kind of say, okay, I'm going to use -3 and -2. Can't use these, those are asymptotes, so I'll use 0. And then maybe like 2 more over here, so 2 and 3. Now my calculators are slowly dying, so if you don't have one today, just look off somebody's.
When you go back, I missed out the table.
Yeah.
Sorry.
Okay.
How the heck do we find the domain of that? Oh, we plug in. Oh, because, yeah. We just set it up so that x is 0. Or wait, no.
What's that? What are you asking about?
Like, I'm trying to remember how we find a we just plug in something for x.
Yeah, we're going to use our calculators to plug these in.
You see, I was just wondering how we found the domain, the VA and HA and everything.
The VA come from these two,
Yeah.
and the HA is because the bottom power is bigger.
See, that's what I thought. Like,
There's some rules on the other side. We're going to go over that formally in a little bit.
like, see, I don't know. See, it's been a while since
Just hold that thought for a little bit. Okay, here's the graph. By the way, you guys have the same shirt on. Ryan and Kyle have the same shirt on.
Ryan and Kyle have the same shirt on.
Twins.
Was this planned? Brian has
Yeah, we'll see. We can make him smile just for a minute. All right. Plug-ins. Plug in those 5 numbers we picked.
What are you, Ray?
Mine are already on there for X and Y.
Okay.
And how come I'm getting fractions in here?
Ooh, you're lucky.
Oh, wait.
You have it on fraction.
2x plus 1. Is x squared minus 1? Oh, wait, those are the same thing.
Okay.
Oh, I have the same.
Once you get the values, go ahead and fill your table in.
I got fraction mode. I don't know, I'm just lucky.
That's actually kind of nice.
I'm just gonna punch in fractions.
All right, guys. Did we get our graph and our table okay? Oops, you want that? Nah, don't look at that. Okay. All right, so fill it in. Yeah, kind of looks like eyes. Okay, the new part of this is the limit thing. So it says, use limits to describe the behavior at values not in the domain. So what are the values not in the domain? 1 and -1, the asymptotes. So all that's saying is use limits at each asymptote. So for example, that means limit x goes to -1 from the left. You need to fill that in. Limit x goes to -1 from the right. Fill that in. Okay, let's do the first one together. So 1, -1 from the left. Where's it going? Infinity. Now we know, guys, we know there's only 2 possibilities here, right? Because it's a DA, it's gotta be infinity or negative infinity. This one's infinity. What's this one doing from the right? Okay. Now try the last 2 on your own. We're gonna go to 1 from the left and 1 from the right.
Why is there a minus like superscript above the negative? Why is there a superscript minus above the negative?
That is the new notation that indicates from the left.
Oh, I'm sorry.
That means
So from the left of -1, it is from the left of the asymptote.
yes.
X goes to. Oh, yeah, so basically, left minus means left to right. It's kind of the opposite of what you think it is. I am okay. I'm sorry I didn't catch that. Am I out there with it? What
All
that
right,
means?
ready? Grant, what did you get? 1 from the left.
Positive.
One from the left. Here's the left of one, right, Grant?
Negative.
Oh, sorry. I
Okay.
couldn't read it because it opened.
From the right?
Positive.
Okay. Any questions on doing that? Promise it's either gonna be positive or negative. Okay. Moving along. All right, this guy, girl, sorry.
Okay.
I'll come back to you in a second. This was one of our basic functions, yes? Okay, with your pod, do this, analyze it. If you want to use a table of values, use -2 through 2, no calculator.
Way away.
You want me to go back, Paul, or you?
I don't know. Yeah, go back. At least I'll get it. You know what I mean? All right. I got it. I don't want to talk about politics.
I know, but what do you think of it?
I think this has to happen.
I just want to know what you think.
I am finished. Okay, good.
What is?
Why? No,
Let me think about
We're
what.
supposed to be working on this.
Yes. I'm trying to think about PSATs now.
And pencil buttons on top of it.
Oh, I just ran out the levy that one. Oh, no, I'll do this. Yeah, I'm after that. Equals, wait a second, what were there, these ones I missed?
You have the top of this one. Then you just
Can I get a one?
left side and
I got two, how many on board?
this one. Exactly what I have on here.
Oh, okay, how come there's nothing below this?
She had this.
But you see there's one below here, there's one below here, there's one below here, come on.
I don't know. You have that like that. But right now, we're doing the work.
Okay. Can we graph it?
She said no doubt. Right? Wait,
Yeah, there. One over two. I wrote error for this like it's a calculator. Hey, I wrote error for like it's a calculator. That's how you know I'm going over the edge. I'm actually like
doesn't take that long.
I know. Okay, there we go. I know. -2, -1, -1, 0 is just nothing, 1, 1, 2, 1/2. There we go.
No, we'll check it.
If it's like a bump,
Wait with anticipation.
if it's like a bump or a hit, I forget how it is. Oh, no, it's not a bump.
Oh.
What photos? What photos like? Remember? I work better when you talk with me. Oh, now let me talk to him.
All right, check your answers.
And that's a good thing to do.
I don't think it helps.
You did what?
So I was so confused because I was putting like one and one half of it was going up, those 3 years and half.
Yeah.
You have to put the edit here.
Yeah. It does.
So the end behavior is when you go to infinity. So as you move to infinity, the y coordinate is going to 0. Okay. As you go to negative infinity, it's doing the same thing. So therefore, I just put them in 1. Okay. But you don't have to. You can split them up if you want. Guys, if you don't like them together, you can do this as well. But anytime they do the same thing, it's nice to combine them, but it's up to you. Do you have any other questions about what's up there? Okay, so everything else we're going to do today, this is the most basic rational function, right? 1 over x. Everything else we do is just going to be some sort of movement, stretch, transformation of that. Okay? Okay? So, I'm going to move on.
Okay. Or I just get it from somebody to get on.
Alright, this is kind of like your go-to slide. Guys, listening?
Or a
This
gym.
is like your go-to slide. You're not going to have this on the test, though, but it has all the rules. So, I had mentioned this. We had these before. These are the HA rules. Okay? So when the top power is smaller than the bottom, we automatically have y equals 0. Okay, we did that earlier. If they're the same, then you divide the leading coefficient. And then this is new. Before, I had you say, if the top was bigger, there just wasn't an HA, and you stopped right there. Said none. But now, are you ready for this? We have what are called slanted asymptotes. So we can have, and we're going to do one in a little bit. where it's approaching a slanted line rather than just like a horizontal line or a vertical line. Like
Where do
that.
you use origins? Origins.
What's the point?
If you're a math teacher, yeah.
No.
I'm sure there's an application. Okay, ready? Vertical asymptotes, we know how to do that, use the bottom, okay? X-intercepts. Find an x-intercept in general, you're setting y equal to 0, right? Now, I shortened it for you because if you think about it, we have fractions, right? Y equals stuff over stuff. If I make this a 0, doesn't that mean that the top of the fraction has to be 0 in order for a fraction to be 0?
Yeah.
So you can shorten and say you're just setting the numerator or the top, right? Equal to 0. And then y-intercept straightforward, you just sub in x equals 0. All right. Any questions on the cheat sheet?
No.
Okay.
Use this on the test.
No. So the first thing we're going to just do is practice the asymptote rules. So let's do the HA first. And just looking at this, what is the HA? 3. Same power. So you take the ratio 3 over 1. So it's just y equals 3.
The VA plus or minus 1.
Well, let's see. So to do the VA, what were your thoughts on finding it?
We should just like set that to, it's like 0. We should just set that to 0.
Okay.
Subtract 1. It doesn't look like it's gonna come out. Square root it, and it doesn't come out. So
So
it's gonna be imaginary.
it's going to be imaginary, yeah. So what does that mean about our VAs?
There ain't any real ones.
Say that again.
There ain't any real ones.
You didn't say ain't, did you? That second?
Ain't.
No. All right. Paul did a nice job explaining, other than using the word ain't.
I talk I wanna.
So when you set the bottom 0, you get imaginaries. That means there's no VAs. Okay, let's do the HA again on number 2 first. Where is it located? Not 1, 0. Because the bottom is bigger power, yes? This is a 1 power, this is a 2. So we're good. VA, we would set the bottom to 0. So we can factor out an x. And we would want to check too that neither of these canceled with the top, and they don't, right? No holes or anything. So we get 2 VAs. One is at x equals 0, and the other one is at -3. All right, any questions on that? Okay, now we're gonna do 2 big problems where we analyze it, forever. So it cannot be analyzed anymore. Okay, can you factor the bottom of that, please?
Okay. Pretty quick.
You did it.
It feels so weird. What's it feel weird on your head?
not reading like she doing that.
What?
I think he enjoys that.
I was asking you, it felt weird on his head.
Alright, so I'm gonna do these kind of a little out of order, okay? So let's start with the HA. Bob?
Question?
The HA, the horizontal axis.
0.
And that was because,
Because the power below is higher.
perfect. Okay, so we start that. And here's a fun fact. If you have this, you can have this. You can have both. Okay? So make a note to yourself. Can't have both. Okay, so we have that section done.
What is an SA?
That's our slanted asymptote, which we're going to talk about on the next example.
Oh, I think I know what
Get
that is.
excited. Okay, how about the VA? Marcia, what do you think?
3.
Okay. So that came from our factors over there. And then when I find the VA, I like to answer the domain. So those go together. VA and domain. Domain is going to be everything but the VA. So negative infinity to negative 2, negative 2 to 3, and 3 to infinity. All good so far? Okay. Range, we're going to wait on that for a minute. Okay, y-intercept, I love this. Y-intercept, you're plugging in 0 for x, right? You should be able to visually look at it in its original form and tell me what y would be. X is 0. 1/6. Look, it's like if you just cover up all those x's, right? Negative 1 over negative 6. So 1 over 6. And then setting
Yeah.
setting y to
Oh,
0.
did you get this? Oh, but I know how we got. We just set x to 0 and solve.
So if I set this to 0, remember I mentioned this. If this is 0, that means x minus 1 is 0, right? So therefore x equals 1. Okay, any questions on what's up there so far?
No.
Okay, so at that point on a test, you would get those things, and I would want to see all those things graphed explicitly. Okay? So I'm going to graph those 2 points and those 3 asymptotes. Abrams, are you upset by something?
No.
Are you upset by that 1 point? I felt like you were.
One liner is
I think he is. If you're upset by the point 1, 0, you should be, right? Because you're thinking, are you thinking that we've been lying to you all this time? Do you see what's happening? Yeah, you see it? Shooting signs? No idea.
Wait.
There's a point on the asymptote.
Oh no.
I promise we haven't been lying to you. So, the true definition of an asymptote is that it just has to be approaching it on a portion of the graph. So you're going to see when we do the graph that on the the outer two pieces, it's a true asymptote, and in the middle is crossing through it. So it's kind of crazy, right? So at this point, then I would have you make a table appropriately. So use some X values you haven't used yet. So like -4, -3, -1 and 2. And then maybe 2 more over here, so 4 and 5. What's wrong?
How do we get those points there?
Ghostbusters song. No, I'm not.
I'm just picking numbers around the asymptotes that we haven't used yet.
And plugging them in.
Yes, we are going to plug them in within our calculators. So when you're ready,
It's not on the origin. That one point on the origin.
no, that's this point 0, 1, 6.
No, I mean the other point.
Yeah.
Oh yeah, it is. My bad. I should just.
So I like to type the original in because there's less parentheses to worry about. So you type the original in and you go to your graph, you're going to see that it will be crossing there in the middle. And then go ahead to your table and type in those values that we picked. Need help? Please.
Yeah. Can't get it, graph.
Okay, we still have two things to answer. Notice I had us wait to do the range, yes? Any thoughts on the range? Nick?
Wouldn't it be all real to the dust cross?
It does. So I advise you to wait on the range. Every problem, it does something weird. Because normally we would think it would exclude 0 because of the asymptote. But notice it crossed it, so we actually picked up 0 in the process. So Nick's right. Range is actually all real.
Why do you have like what is okay marked?
Because at this point it crossed its asymptote here.
Why? How is that allowed?
So we had a conversation about it. I think you were out of the room. So it's okay. It's still an asymptote because it's an asymptote over here and over here.
Oh,
Okay?
now I see. It doesn't have to apply everywhere, just to some things.
Right.
Now I have
Okay.
another question. How do we why is the range all real numbers if there are blank areas? Oh, because it's y time.
Yeah. All right, guys, the last thing. I didn't leave you enough room, sorry. The limits at the VA is that new notation, the limit from the left and the right of the asymptotes. So let's do limit x goes to -2 from the left.
Yes.
So -2 from the left is going down, so negative infinity. -2 from the right is going up, so it's infinity. Then I'm going to come down here and do the other two. Limit as x goes to -3 from the left, or I can count 3, my bad. Yeah, we're going left and right of both of the asymptotes. -3 from the left is negative infinity. And then 3 from the right is infinity.
I don't understand like left and right.
Okay. Okay, find -2, for example. Here's -2, right? Okay. So here's the left of the graph, right? Okay, so you're traveling on the graph towards -2 from the left.
Which graph does this go? Oh, I'm just on the right graph, thank God.
If I'm traveling on the graph towards this value, from the left is going down. Okay? From the right of the graph, you'd be on this piece. So from the right, you're going up. Better? And then left here is down, right here is up. And because they're VAs, Kendall, they're always going to be either plus or minus. Okay? Yeah, Aiden.
Why is it limit f of x for when you're going left? Negative. Can you explain what you got?
Why is this one negative?
The other one.
3 from the left. So 3, here's 3. And I'm on the left portion of the graph approaching 3. It's
Oh,
going down.
so it's like approaching 3 or 3 approaching meters out.
Approaching 3 from the left is what that means. Anything else? Again, guys, the notation. Look again. This means approaching 3 from the left, from the negative direction. If you want to think of it, from the positive direction. All right, we gotta do one more. Get through the other case. Go ahead and factor the top, please.
Trying to remember. Okay,
Guys, this is not homework. Get rid of that. That's old. There's like a page number on it. In class exercises. I don't think we're gonna have time for that. All right, guys, let's go. Let's start. Let's go. Let's just go in order. Something different. X-intercepts. You're setting the top to 0. Yes. Okay. If I set the top to 0, what do I get? 2 and negative 1. So I have 2 comma 0 and negative 1 comma 0. Y-intercept. I'm setting X to 0. 2/3. So 0 comma 2/3. All right. Where's the VA located? 3. Okay, here's what's going to be new. Is there an HA? There's not, because let's go back to the cheat sheet here. We are in this case right here, where the top is bigger than the bottom. So we know there's no HA. So we are going to do this new part where it says there's a slant asymptote. How do we find it? Well, it says long division, but you can actually just use synthetic division. The slant asymptote is the quotient only. The remainder you don't look at. Okay, so let's go here. Whoops, I'm going the wrong way. Okay, so go ahead and put none for the HA. So the essay, here's what you're going to do. You're going to divide. So if I'm dividing in this problem, what am I putting in my box? 3. And then you got 1, negative 1, negative 2. All right, just go ahead and do your division. Okay. So, this, where's our remainder, right? We don't pay any attention to that. And then we have our constant and our x. So we got a linear quotient, right? Y equals x plus 2. X plus 2. And we'll deal with that in a minute when we graph it. Very cool. Just wait, yeah? And then the domain would go with the VA. So domain is everything but 3. Okay, so I'm going to graph this line, and those 3 points to start. Okay, when you go to graph the x plus 2, you graph it just normally, but I'm going to make it dashed because it's an asymptote. So start up at 2, and then it has a slope of 1.
So what's our slope?
Slope is 1.
Oh, sorry. How do we tell the slope? I forget.
The number in front of the x gives you.
Oh.
So mx plus b.
Or just x, or just the xx. Oh. Oh, we
It's already in
divided.
mx plus b.
We divided.
Yeah.
So we divided it by 3, and why do we divide it by 3? I'm sorry, I'm out of it. I missed this part.
So you're taking the original problem up there.
Yes.
See the original problem? Paul?
Yes.
See how it's that quadratic divided by x
Yes.
minus 3?
Yes. So now
Okay.
what? So that's why we divided by 3.
Yeah.
Oh, now I see.
All right, we need to pick a few points. Ready? This is almost done.
Yeah.
All right, guys, here's what I'm gonna do here. In this little region, we're pretty much done. Why don't we just figure out what we get when we plug in 1? That'll be enough there. And then over here, let's use, what's this, 3? Let's just use 4 and 5. Make it easy. And again, we're gonna type in that original graph. So, area minus x minus 2. And I would suggest do this as well. You ready? In y2, why don't you put the slant asymptote, the x plus 2? Because if you did it right, your graph should be almost trying, it should be trying to touch that line. Okay? So you can see, check it out. See how the blue is approaching the red?
Oh, yeah.
Pretty cool. So let's finish it up. 1, 4, and 5. So 1, 10, and 9. Okay, range. This has a big gap in the middle, doesn't it? So it goes, hey, listen, we're almost done. Goes up to 1. Does it include 1? Then it picks up again where? At 9. So your range is negative infinity to 1, bracket, union, bracket, 9 to infinity. One more thing, the limits of the VA. I'm just gonna put them down here. What's that? Yeah, from the left it's going down, from the right it's going up. That's pretty cool, isn't it? Now notice, you're gonna have a bunch of time later this week to work on everything. Everything just due Monday, just to be easy, okay? So you have plenty of time Thursday, Friday to be doing stuff. All right, we did it. Tomorrow we're doubling up on 2 small lessons, and then we'll be done with chapter 2.
I screwed up on the word Please keep that up, I made a mistake.
Everything's due Monday, all the homework. Yep, and the reviews due Tuesday, which I'll put them tomorrow.
I made a mistake, will you keep that?
Yep, you're good.
They actually paid attention today.
I know, it's amazing.
Hey guys, the ice is not part of the homework. We didn't have time to do that, so I just started
What if we would? I would. I don't know. You're very The first time I took it, I got like this. You wrapped the all because I'm like, hey guys, I'm looking at this, but I don't know why.
Really, I'm definitely not. I know what I'm doing right now.